All right, you are welcome again. Let's take this question. Find the integral of cos x cos 2x dx. Find the integral of cos x cos 2x dx. So in this question, we're going to be making use of integration by part. Okay, so we're going to make use of this formula. Integral of u dv is equal to u times v minus integral of v du. All right, so our major concern here is to identify these terms. So like u are dv, are u, are v, and then du. So once we have bring these terms out, we can then join them together and do what we know how to do the best. Now let's go. In this question, we have integral of cos x cos 2x. So we can simply say let u equal to cos 2x. Let's call cos 2x to be our u. So in this case, the other term that is remaining, that is cos x dx, we can call that what? Dv. So we say let dv equal to cos x dx. All right, yes. Now here we have u equal to cos 2x. Let us differentiate this with respect to x. That means we are going to have du all over dx is equal to minus 2 sine 2x. All right, yes, we have du all over dx is equal to minus 2 sine 2x. We are interested in making du the subject. That means we are going to cross multiply. So when we cross multiply, we're going to have du is equal to minus 2 sine x dx. All right, yes, let's keep this. Now let's go to the other side where we say that dv is equal to cos x dx. You know, when we say dv, we're talking about the derivative of v. And then when we say dx, the derivative of x. So it is in form of, or is in derivative form. So we want to remove it from derivative form. So for us to remove it from derivative form, that means we're going to integrate it. You get it, right? Yes, it is in a derivative form, and for us to remove it from derivative form, we are going to integrate. So when we say the integral of dv equal to the integral of cos x dx, so when we take the integral of dv, we're going to have just v, and then when we say the integral of cos x, is going to give us sine x. All right, yes. Now when you look closely in what we have solved so far, you'll see that we have obtained a u, you have obtained dv, we've obtained v, we've also obtained du. All right, yes. And then our formula say that the integral of u dv is equal to u times v minus integral of v du. All right, yes. Now let's bring together all the terms we have gotten. So here we say the integral of cos x cos 2x dx is equal to u is cos 2x times v. What is our v? Our v is sine x. Then we say minus integral sine. Our v is what? Sine x times our du. We have minus 2 sine 2x dx as our du. All right, yes. Now let's go. Let's multiply very well. So we're going to have the integral of cos x cos 2x dx is equal to cos 2x times sine x minus integral of, when we multiply this term in the bracket, we're going to have minus sine x 2 sine 2x dx. Okay, so this place now, we're going to take these two outside, and then when we say minus times the minus in this integral or inside this integral, then we're going to give us positive, right? And then we take the two outside. So that means we're going to have the integral of cos x cos 2x dx equal to, then when we combine this cos 2x and then sine x together, we're going to have sine x cos 2x plus, you know, the two outside now, 2, then we have our integral sign, integral of sine x sine 2x dx. All right, yes. Now when you look at this very well, discover that this part that is having integral sine x sine 2x, The x is actually looking like the question we have. That means we are going to focus on that part. We're going to differentiate that. If care is not taken, we may be doing this until tomorrow. Okay, but let's see how it's going to be. All right. So now let's take a look at this very well. You see, integral of sine x sine 2x dx. With our question is almost the same. That means all these things we've done before, let's repeat the step again. But let's see what we are going to have now. Okay, now let's go. We can simply call sine 2x to be our u. All right, yes, and then we'll say u equal to sine 2x. So let's differentiate. The u all over the x is going to give us 2 cos 2x. Is that true? Yes. Let's also make the u the subject. So when you make the u the subject, we're going to just cross multiply. Then you will have du is equal to 2 cos 2x dx. All right, yes. And then since you have made u to be sine 2x, the remaining things there is going to give you your dv, which is sine x dx. So we can simply say that our dv is equal to sine x dx. All right, yes. We have the derivative of v, which is dv. So we're going to take the integral of it so that we can obtain our v. So when we take the integral of it, we're going to say integral of dv is equal to integral of sine x dx. So the integral of dv is equal to v equal to integral of sine x is going to give us minus cos x. All right, yes. Here we also have obtained a v, dv, u, and du. All right, yes. Now our formula will say that integral of u dv is equal to u times v minus integral of v times du. All right, so let's fix it together. We have the integral of sine x sine 2x dx is equal to our u now is sine 2x multiplied by our v, which is minus cos x, minus integral sine. So our v is minus cos x times our du is 2 cos x dx. All right, yes. Now let's simplify. So when we say sine 2x times minus cos x, it's going to simply give us minus sine 2x cos x. All right, then we have minus integral sine. So in the bracket, we can simply say minus cos x times 2 cos 2x is going to give us minus 2 cos x cos 2x dx. Is that clear? Yes. Now let's go. We can take the minus 2 outside to multiply the minus outside the integral sign. Okay, so when we do so, we're going to have minus sine 2x cos x. So minus times minus going to give us plus, and then the 2 we are taking outside, 2 integral of cos x cos 2x dx. All right, yes. So here now we discover that what we are solving, we just looked for the integral of sine x sine 2x dx. So in the place of this integral sine x sine 2x dx, we can replace it with the value we just obtained now. So the value we obtained now is what? Minus sine 2x cos x plus 2 integral of cos x cos 2x dx. All right, so let's replace it. If we replace it, we are going to have integral of cos x cos 2x dx equal to sine x cos 2x plus 2. In place of this integral, whatever we have there, right? We can replace it with the value we obtain now, which is minus sine 2x cos x plus 2 integral of cos x cos 2x dx. Is that true? Yes. Now, we have a big bracket, right? Let's just open the big bracket. If we open the big bracket, we're going to have sine x cos 2x. We have plus 2 times the first part, which is minus 2s cos x. We're going to have minus 2 sine 2s cos x. All right? Yes. Now we say this same plus 2x multiplied by the other side that is having the integral part. We're going to say 2 times 2. We're going to give us what? 4. And then we have integral cos x cos 2x dx. Is that clear? Yes. Now from here, we are having integral of cos x cos 2x dx is equal to sin x cos 2x minus 2 sin 2x cos x plus 4 integral of cos x cos 2x dx. So you discover that the last function we are having is what? 4 integral cos x cos 2x dx. And then the original question that's given to us is the same integral of cos x cos 2x dx. So we can take this last part to the initial. So as it is going to the initial, it's going to give us the negative, that is minus 4 integral cos x cos 2x. All right, let's take it that side. We're going to have integral of cos x cos 2x dx minus 4 integral of cos x cos 2x dx equal to the remaining values: sin x cos 2x minus 2 sin 2x cos x. All right, yes. Now we are having integral of cos x cos 2x dx and then minus 4 integral of cos x cos 2x dx. It's just like saying 1 minus 4. So when you say 1 minus 4, it's going to give us what? Minus 3. So we're going to have minus 3 of integral of cos x cos 2x dx, all right, equal to sin x cos 2x minus 2 sin 2x cos x. Is that true? Yes. We are interested in finding the integral of cos x cos 2x, not minus 3 cos x cos 2x dx. All right, so we can simply divide through by minus 3 so that this minus 3 can go. All right, so when we divide both sides, we are going to have minus 3 integral of cos x cos 2x dx divided by minus 3 is equal to sin x cos 2x divided by 3 minus 2 sin 2x cos x divided by minus 3. So when we cancel in the left hand side, we are going to have integral of cos x cos 2x dx is equal to, we can simply factor out 1 all over 3. So we have minus 1 all over 3 sin x cos 2x. Now this is going to give us plus, right? So we're going to have plus 2 all over 3 sin 2x cos x. All right, yes. So we can rearrange our values. All right, so we can simply have integral of cos x cos 2x dx is equal to 2 all over 3 sin 2x cos x minus 1 all over 3 sin x cos 2x. All right, yes. When you look at this value very well, the terms we're having on our right hand side, you can see that there is something we have in common, so we can just factor out something. So we can simply factor out 1 all over 3. So when we do so, we're going to have integral of cos x cos 2x dx is equal to 1 all over 3, and then in the big bracket, what is the remaining is 2 sin 2x cos x minus sin x cos 2x in bracket plus c, so that when you say 1 all over 3 times 2 sin 2x cos x is going to give you 2 all over 3 sin 2x cos x, and then when you say 1 all over 3 times minus sin x cos 2x is going to give you minus 1 all over 3 sin x cos 2x. Then in brackets we say plus c. All right, yes. Please, I want you to listen to this, watch this gradually over and over again so that you will understand better. All right, yes. Let's take more example for easy assimilation. Let's go. Thank you.